Hi, welcome back. In this video, we are looking at comparing means. We're going to start with this example. A researcher at Cornell University wanted to know how friendship might affect simple sales. She randomly divided subjects into two groups and gave each descriptions of items they might want to buy. One group was told to imagine they were buying from a friend whom they expected to see again. The other group was told to imagine they were buying from a stranger. The prices offered for a used camera are shown below, down here in dollars. Is there a difference in the price people would offer a friend rather than a stranger? What is the 95% confidence interval estimate of this price difference? All right, so this is our setup. We have a well-controlled experiment run by Cornell University in which we're trying to see if there is a difference in the mean price offered for a used camera. So this looks like we are going to be doing a two-sample test of means. So we're going to start by checking our assumptions. So the first assumption for a two-sample test of means is that we need independent groups. We have a well-controlled experiment with random assignment to groups. And this is going to satisfy the criteria of our groups being independent. So if we have a well-controlled experiment and we've got a well-controlled randomized experiment, then our independent groups will have been met. Our independence criteria when we're looking at an experiment is different. Our subjects from an experiment are not required to be randomly chosen from the population. Instead, our random assignment to treatments satisfies the random criteria. And the 10% is not required because of the experiment. So when we're looking at a well-controlled experiment, really the main things we're looking at is that we have a random assignment to groups. That's going to make sure our groups are independent, and it's also going to end up satisfying our independence criteria. The last thing we need to do is check the nearly normal condition, and we need to check this for both of our data sets. So I have my price offered for a friend, and I put this into list 1, and my price offered to a stranger, I put this in list 2. So to check my nearly normal criteria, I am going to graph a histogram for both of my data sets. And then I am going to, so let's actually make this 315. Let's make these 15. So I'm going to graph histograms. So this is for my friend data. And so this looks like this. So this appears to be unimodal, skew left, and there don't appear to be any outliers here. I can't tell that exactly from my histogram if I went in and looked at my box plot. Here I can see clearly that there are no outliers. Okay, so now I'm going to do a histogram of my stranger data. So this is stranger. And this appears to be unimodal. It's approximately symmetrical, and there are no outliers. So if I look at my data for list 1, the friends data, there appears to be 8 observations So 8 observations is big enough here because I don't have any outliers. I have some skew, but n equals 8 is going to be big enough, and here n equals 7 is big enough. So the conditions have been met to perform a 2-sample t-test of the mean. And now we're all set up to start our test, which we'll do in the next video.